It's just a science project.
Silent breed is people!
You know, a doctor friend once said the same thing to me. Frankenstein was his name.
It's alive! It's alive! It's alive!
That sounds like something out of science fiction.
Please explain to me the scientific nature of the whammy.
We live in a spaceship, dear.
So?
Yes, science!
Program complete. Enter when ready.
Hello and welcome to episode 235 of Science on Top for Sunday the 24th of July 2016. My name's Ed Brown and with me today, microbiologist Dr. Shane Joseph.
G'day.
And a level 25 Pokemon Go player, Lucas Randall.
No, I'm not actually. I've avoided that, and that won't be happening.
Oh,
you're a hater, man. What the
yeah.
not a hater. No, my kids, two of the kids are playing it. The wife's playing it, and none of them can explain to me what the hell the point is.
Look, I am. I mean, while we're on this subject, I usually hate everything, as you know.
True, that's true. That's been my observation.
I don't hate, but I don't hate this, and I'm very confused by people who do hate this.
Are you playing it?
I'm
not playing it. And look, the whole Pokemon phenomenon sort of bypassed me because I was too old.
Yes.
And I've watched the cartoons every now and again and gone like, this is giving me a seizure, so I'm going to stop now. But I get why people like it, and I actually think it's really cool. I like the way that people go out and hunt this stuff in packs. You know, I think it's it's almost like a sort of it's bringing people together that normally wouldn't be together, and I think that's kind of cool. I mean, I must admit, when the person first showed me this at work, I looked at this and went, what the hell is this rubbish? But the more I thought about it, the more I thought, I'm just being an old curmudgeonly fart and I should stop. And, yeah.
And now's the time you decided to stop being that.
Yes, it had to happen sometime, but it did happen, Lucas, all right? I think it's kind of cool that it's happening, and I'm very amused by all the hatred it gets.
Yeah, I don't get that. That's a lot of people just standing on their porch going, get off my lawn. That's what it sounds like to me.
And, you know, and usually I'd be amongst them saying get off my lawn, but this time I'm not for some reason. I don't know why.
No,
right.
I
anyway, we should do a show, shouldn't we?
Today's show is not actually about Pokemon Go. No. What we are going to be talking about is how the solar system is kind of off kilter, and that might be all Planet Nine's fault, and some worrying news for gonorrhea sufferers. You've got gonorrhea.
As if they didn't already have enough worrying news.
But first, Lucas, it's been just over a year now since the New Horizons probe flew past Pluto.
Yeah.
We did a whole show about it. It was thrilling to see that heart shape on Pluto, the red discoloration that might be dust from its moon Charon being sucked over to Pluto. But I think it was only like a 15-minute flyby or something, and it was going to be months for all the data to come back to Earth, and who knows how long after that to analyse that all. But as I said, it's been just over a year now, so what have we learned?
Well, for starters, the data's all back. So, yay.
Yay!
That's
cool.
So
it's finished now, is it?
Yeah. I don't exactly know when we receive the last of the data, but yeah, all the photos, all the readings, everything. It's all back now, which is pretty cool. It's going to take, I think, years for the scientists to work their way through it because there's just so much. But yeah, over a year. I cannot believe it's been over a year for starters.
It doesn't feel like a year, does it?
It really does not.
I remember showing someone at work this, and again, and you know, going, look how cool this is, and them looking at me going, this is, I don't understand, and my heart broke a little bit.
Yes.
But yeah, that was a year ago. That's kind of crazy. It doesn't feel like that long ago.
Yes.
You need better workmates.
I know.
So, I mean, there was a couple of, I guess, retrospectives that popped up online, and I particularly like Phil Plate's one from Slate blogs, which was a nice sort of summary of what we've learned and what we now know about Pluto that we didn't know before. And I won't go through the whole lot because there's quite a lot of stuff that he's got in there, but I guess I've picked a few things that were particularly stood out for me and are quite important. I think one of the first things that really surprised, or as Phil said, shocked scientists, maybe, dare I say, baffled them.
I was so going there.
was the lack of cratering on certain parts of Pluto.
Yeah.
Cratering is one of those things that you expect to see in pretty much any planetary body, and Earth's a little weird because if you look at Earth, you don't see a whole lot of craters. And the reason for that is because we have a geologically active world. We have plate tectonics that are driving a constant repaving and resurfacing our surface of the planet. So the craters that we do have tend to get covered over pretty quickly. There's mountain formation. There's movements that are occurring, but most of the rest of the solar system doesn't have that anymore. In fact, it's one of the things that's quite special about Earth, that we still have these tectonics. You look at Mars, for example, Mars, which at one point in time we believe was very, very similar to Earth in terms of having oceans and having a magnetosphere which looked after the atmosphere and stopped the solar wind from blowing it all away and so forth. One thing it really lacked for a long period of its history is plate tectonics. So you look at something like Pluto and you think, how could something so small have plate tectonics? And it doesn't appear to have plate tectonics in the traditional sense, but there is we believe there's a similar process going on Pluto, and it's really everything's weird, right? Because it's so cold. And one of the things that's driving a process over there, they believe, is basically similar to here. There's probably some radioactive decay of certain rocks in the center of Pluto, which are producing heat. We know it can't be tidal forces because Charon and Pluto are just too small to exert that much energy, tidal energy on each other. So it must be some internal heat. But it's kind of cool to think about this, but there's basically evidence which links into some of the other things that we've seen in the flyby, that there's a water ice under the surface of Pluto. In fact, a lot of water ice. And water is kind of weird in one of its behaviors is that when you freeze water, of course, it expands. So the water expanding as it freezes under the surface, so as it goes through these processes of melting and then freezing and melting and then freezing under the surface, and of course being under the surface there's pressure, so it doesn't sublimate directly. It doesn't go straight from the ice stage straight into gas. It means that there's effectively the potential for convection currents to be occurring underneath the surface of Pluto, and there are also signs in some sections of the planet's surface of basically what are sort of similar to the plates on Earth, except these are great big ice plates, which is kind of cool. So we're seeing movement of ice and repaving of the surface of these great big ice sections with processes that are similar to plate tectonics on Earth, which is really, really cool. But different things driving it.
That's amazing. And so presumably you've got that similar to plate tectonics, but to smooth out the surface, then there must be like sublimations of the surface going under and being replaced by newer ice.
Sort of.
Is that right?
What we're talking about here, the ice on the surface, though, is actually basically frozen nitrogen, not frozen water. So the water's underneath this sort of shell. So we're seeing basically what they think the best guess at the moment, because obviously we just don't know yet. What New Horizons has done for us is created a whole lot of new questions that we didn't know we had. So, because in reality we expected to see a fairly featureless, barren, icy world, and that's we saw anything but that. So they're thinking, and I'll read from Phil Plate's blog here because I think he puts it best here. The best guess is what we're seeing is a frozen nitrogen shell covering up a more liquid or fluid interior. Some source of heat deep inside Pluto is causing convection under the surface, with warm fluid rising and cooler material sinking. The segmented plates are the tops of these cells of convection, with warm stuff pushing up in the center of the plates and the cooler material sinking around the edges. So it's very similar to what we see on Earth, with the plate tectonics here in those subduction zones. Yeah. So, really cool. So other things. Yeah. We also see these sort of pockmarks or pits on some of the more smooth areas of Pluto. We don't know what they are. We actually don't know what they are, but they appear to be aligned with each other, which makes them even weirder. I mean, the photos that I'm looking at right now is if you were to look down on, say, a satellite image of Earth or something from taken from quite high up, if you could imagine herds of cattle or similar sort of roaming across the plains, that's what it looks like. That's not what it is. We're pretty sure of that. It's not some kind of ice beasts or anything, but
White Walkers.
Winter is coming. But we do have some theories about this as well. Or I'm not taking any credit for any theories.
Go on.
But there are some theories about this, and this is kind of cool as well. Basically, there's one theory that these might be sublimation pits. So I mentioned sublimation before. This is when a fluid or a material goes directly from its frozen state into a gas, and this is what happens when there's no pressure. There's no surface pressure at all, no atmospheric pressure, or very little. I'll come to the atmosphere in a moment because that's also cool. So one of the theories about this is perhaps these pits are effectively uneven areas on the surface, which, as I mentioned before, are effectively frozen. It's frozen nitrogen. It's like a shell of nitrogen, and potentially, if there are uneven surfaces, then the sunlight would actually warm these surfaces unevenly. So the uneven ones might actually be going directly from the gas the solid directly into gas, and then effectively it's like evaporation pits, if you like, and the evaporation pits then cause these sort of gas of nitrogen to hover around in the area for a while, and we may be seeing some of these pits through this process actually getting bigger and bigger and bigger. But then, of course, they eventually get repaved because it's in the same area. You mentioned that sort of heart-shaped area before. This is actually on the Sputnik planum, which is a part of that sort of the left lobe, the left-hand side of that. So they're kind of cool. We don't quite know what's going on there. As Phil Plate said, weird. True. It does seem a little bit weird. There's also some I mentioned the plate tectonic-like things before. There are cracks in the surface of Pluto, which is what makes us think that we're seeing this sort of process, this convection process going on.
Yeah.
So yeah, that's kind of cool. I mentioned the atmosphere just before. That was one of the other really, really cool things, and certainly not something we expected to see on such a small body so far away. Not only, first of all, I'll explain what happened. They obviously, as New Horizons went past, it turned around and it took some images of Pluto, some very close-up images of Pluto, backlit by the sun. And doing that, it allowed us to, get some really cool images that showed these layered sort of levels of atmosphere. But, of course, we were able to take some spectra and so forth of those as well to give us an idea of what's actually in the atmosphere. And what they found was there are basically these really cool layers, dozens of layers, very distinct layers. You see them in the images, and it looks like an image processing error, but that's actually what they are. They're these very, very distinct changes between the layers of either different density or different materials, which was, again, a little bit freaky. And what they think is that these layers are composed of these sort of like complex organic molecules, and they build up. Basically, ultraviolet light breaks down the simple molecules like methane, and then they, to quote Phil Plate, they reorganize themselves into molecules like acetylene and ethylene. And these different layers of different densities, things are causing these very cool sort of layers in the atmosphere, which is kind of nice.
I was even surprised that there was an atmosphere to begin with, because there's no magnetic core, as far as I know, that would stop the solar winds from disrupting it. Obviously, the solar winds and weaker.
Solar wind is obviously something that's being so far away. The solar wind is not quite as severe a problem as it is on the inner planets. Because here, as I mentioned before with Mars, the lack of a magnetosphere is part of the reason why its atmosphere got blown away partly by the solar wind. There are other processes as well, but with Pluto, it's so far out that that may be less of an issue. But it also does indicate, of course, because this is a world with significantly less gravity, that it would, if you think of the exit velocity required for gases to escape the atmosphere completely and just sort of leach off into space, they wouldn't be very high, which means that in all likelihood there are processes that are renewing the atmosphere there as well, because we would expect that it probably would have all just sort of leached off into space by now.
Okay.
So again,
cool.
another tantalising, glimpse into the activity that's taking place there when we thought it would just be a barren, featureless, dead world. It's anything but. Another cool thing I mentioned just before, which I only learned today in reading this article, was because a major component of the atmosphere of Mars is not Mars, sorry, Pluto is nitrogen, just like Earth. Nitrogen is the thing that gives us our blue skies. So it's an effect caused by something called Rayleigh scattering, which is where the wavelengths of light that are hitting the nitrogen particles, nitrogen in the air, are bounced off in such a way that we predominantly see the reflected blue waves. So there's a similar thing that takes place on Mars. If you, sorry, I keep saying Mars, on Pluto.
What's with that?
If you were standing... Yeah, I don't know. You don't see this on Mars. You do not get a blue sky on Mars, but on Pluto you do. You actually get a bit of a blue.
How much light would you see on Pluto, though? I mean,
very, very little. And this is the thing. You'd have to be standing at just the right place, and you'd really have to be standing looking at a sunrise or a sunset, so you're looking right through the thickest part of the atmosphere.
And the actual sun wouldn't even be... It'd be almost as bright as
it
a
would
normal
be
star,
like
really,
a very bright star, exactly. A very, like a bright star that we would see from Earth. I'm not sure how it would compare, say, with perhaps us seeing either Jupiter or Mars from Earth, which can be very, very bright depending on where they are in their orbit, and they can be brighter than the brightest star in the sky, which is Sirius. But I'd say they're probably a little bit brighter than that, but I'm kind of guessing at that.
But it is bright enough that it's that one particular photo that Phil Plait has in his blog of Pluto with the sun's backlight of it, and you see the whole planet, and this blue thin strip around it is absolutely stunning. To think that you're seeing a blue atmosphere from the other side of the planet like that, it's very cool.
You certainly could be forgiven for thinking you were looking at a photo of the Earth from, inside the that cone-shaped shadow behind the Earth, which is what the moon passes through when it has an eclipse. It does look like, you're right. It's a quite stunning. It's a beautiful image.
Yeah.
So some other things that we learned. Let's have a bit. There is more. Let's have a bit of a look at Charon. You mentioned Charon before. Charon. That one of the interesting things about Charon is it has. I really actually considered not saying this, or certainly not using this terminology, but it's true. You can see Charon's got a great big gash right across the face of the moon, and
I'm such a child.
It's freaking. Don't worry, I was the same. So sorry, boys and girls. Ask your parents. So basically, or don't. Yeah. I've lost my train of thought. Now, basically, it looks like a world that's experienced some major upheaval. It's unknown at this point what would have caused this massive sort of line, this gash right across its surface. But it's really, really cool. And at the top, there's some fairly significant impact events appear to have taken place up there, and also this really cool colouring or discoloration up there that we see also on Pluto. So that's, there's some questions there. Obviously, we haven't got a huge. We didn't spend a lot of time looking at Charon, but we've got now some beautiful images from that as well. So we don't really know what's going on there, but we think it's very likely that this is an indication that Charon and maybe some of the other smaller moons might have formed out of an impact event. So if you think of the current, leading theory on how Earth's moon formed, there may have been something very similar that led to the formation of Charon and some of its other moons, which is kind of cool.
Yeah.
I'll probably leave it there. There's a lot more. I do recommend that you go and have a look at Phil's blog post on Slate, and the links will be in the show notes, of course. But it's a gorgeous, summary, I think, of what we've picked up so far.
And as you say, just the tip of the iceberg when you consider that there's still going to be lots of more analysis happening and lots more investigation into so much stuff there. Because I didn't realise at the time that it also took photos and sensor readings of all of the planets, all the moons, as well as Charon and Pluto. So it's going to be very interesting.
And considering how fast it was going, like we're talking about something that was going, I think it was about 50,000 miles an hour or something like that.
It was k's an hour, they said. Yeah, so it's pretty damn quick.
Something like that, yeah. I saw it in the story somewhere, and I've lost it now because it's quite a long one. But yeah, really, really quick. It's amazing that it was able to pick up anything in that sort of in the time frame that it had. 50,000 kilometers an hour. Yeah, there it is. So yeah, really cool.
Yeah. Speaking of things you can pick up, Shane, some worrying news has come out about gonorrhea. This came from the Centres for Disease Control and Prevention last week. It turns out the gonorrhea bacteria may have developed a resistance to the only 2 antibiotics left that can cure it. This is, I guess, not unexpected, really, is it?
No, it isn't. It isn't unexpected at all. I mean, this is the same old story that we see pretty much everywhere. I mean, antimicrobials are usually, originally they were produced by bacteria as a defense line, right? So if you want to clear the area of your competitors, you use these antimicrobials. And of course, in the great arms race against these things, other bacteria develop resistance to them. So in this case, gonorrhea we use 2 antibiotics to treat gonorrhea because gonorrhea has actually been very, very good at developing resistance to pretty much all the antibiotics we treat it with. And the scary thing about gonorrhea is that it also keeps its resistance. So a lot of resistance to antibiotics is actually quite temporary because it's usually born by it's all genetic, obviously, but some antibiotic resistance that some bacteria have is basically what's called plasmid or extra chromosomal, which means it doesn't get integrated into the actual bacteria's genes as such. It's sort of on a piece of DNA that's just picked up and is almost sort of autonomous. So it can lose it very easily in some cases. But in gonorrhea's case, it appears to keep it, as they've tested on samples that are decades old, and a decade old, and discovered they still harbour that same resistance, even though they've gone through multiple generations. So it's kind of scary. Now, basically, the rates of resistance to these antibiotics, I should note that they're not resistant to... There's no gonorrhea that's been detected so far that's resistant to both at the same time.
Well, that's good.
Just one or the other.
It's only a matter of time, yeah.
It's only a matter of time before a strain will develop that is resistant to both. And that's... Yeah, and that's not just in this CDC study. Apparently, these results have been mirrored, I think, in Ontario. Mm-hmm. The Public Health Ontario in Canada has basically discovered the same thing. Similar rates. Now, it's only a bit of a modest jump. I think it was something like
0.6% to 2.5%.
Yeah, which actually isn't that modest when you think about it. Well, that's for one of the antibiotics, which is azithromycin, and the other one, ceftriaxone, rose from 0.4 to 0.8%.
So that's a doubling. Yeah.
It's a doubling, yeah, and again, not huge. Like, we're not talking half the strains we pick up are resistant, but it is definitely a harbinger of what could happen in the future. And gonorrhea is not always it's not like syphilis, where it's it can lead to some pretty serious issues, but not something like syphilis or HIV, for example, which will lead to death. But gonorrhea can cause some pretty nasty effects in if women are infected with it, they can pass these things on to their children if they're pregnant, and it can cause blindness in children. It can lead to infertility in men. It's not nice. So yeah, I suppose the only way we can really combat this until new antibiotics come out, which could be decades away, is to basically use protection, which is a bit of a no-brainer, but it's one of those things that I think we've seen. There's been a bit of a trend, and this is a different sort of topic, but I think there's been a bit of a trend where people use protection less and less because things like HIV are not so fatal as they once were. You can live with HIV a long, happy life as long as you take retrovirals. So a lot of the scare campaigns they used in the 80s aren't as effective anymore, and you have this sort of relaxing of diligence, and that's when these diseases come back. And
it's a lot like how vaccination has dropped off because we're not seeing polio anymore. We don't see in our faces the harmful effects of low vaccination rates, but it's a similar thing with safe sex, obviously.
Yeah, pretty much.
Just a little side note, I remember a wonderful story I heard from one of my mum's friends back in the 70s who was suffering from a gum infection. Went and warned her friends that they should be careful because she's currently suffering from gonorrhea of the gums.
Oh,
and suffice to say, they thought that she had a vastly different lifestyle than that. So that's I think she meant gingivitis, but that was very amusing.
Starts with the same letter. Who's going to know?
Word, it's
Gonorrhea.
I would still not be kissing her anyway. Well, Lucas, let's get back to space for a little bit. And all the planets in our solar system orbit pretty much on the one plane. There are no planets at 90 degrees vertically up, for example. And I should say before we start this story that our language and vocabulary, in my opinion, don't do very well in a three-dimensional relative space. I think it's hard to describe these things well, but we'll do our best. But you'd expect that orbital plane to be around the sun's equator, but it's not. And either the sun is tilted slightly or the solar system's orbital plane is tilted slightly. And a new theory suspects it's the latter, and that the currently undiscovered Planet 9 could be responsible.
Nibiru.
No, it's not Nibiru. Stop that. Stop it at once.
I couldn't help myself. It was there.
You saw an opportunity and you went for it.
Yeah.
Yeah.
So Planet 9.
Planet 9. This is one of those things, isn't it? I remember in the 80s when I was in primary school, and I remember there being talk about a mystery planet, another great planet out there that had yet to be discovered, but they were quite sure it was there. And just in the time since we started this podcast, what year did we start this podcast? Was it 2012?
2011?
2010? Yeah. Just in that time, I think we've covered about 6 different things that might indicate that there's a Planet 9. So it's it's kind of the idea that just won't die. There's another theory. So just as Ed explained in the intro, there's the issue is that the sun doesn't rotate on its axis in a way that lines up with the orbits of the major planets. So all of the major planets.
So it's at an angle of 6 degrees.
Correct. Yeah, 6 degrees relative to the line perpendicular of the plane of the planet. So all the other planets go on this plane. It's called the plane of the ecliptic. It's basically the plane at which the major planets all follow, including the asteroid belt as well, mostly. Yep. So it's indicative of the spinning cloud of dust that basically forms the entire solar system, including the star. And for that reason, you would expect it all to be sort of spinning on the same plane, because it would have been when it formed those objects. So one theory is, of course, another star that might have come close at some point and perturbed either the orbit of the planets or the tilt of the sun itself. This is kind of the nemesis theory, which has been thrown around as reasons why comets could have been thrown at the Earth in various stages of its history. So that's one idea, that maybe there's a star, aeons ago, that was basically causing a bit of a tug on things. Or another theory is another planet. Now, a team at Caltech have been working on some modelling, and no matter what they have done with what we know, they've not been able to really explain this orbital tilt. There's a whole lot of things that they've plugged into their models, but of course models are only as good as the information you provide to them. One thing they have tried, though, is they've added another planet on a very eccentric orbit. We're talking about something that might take perhaps 250 times the distance between the sun and the Earth at its furthest point, but then coming quite close in on the other part of its orbit. So something like that would also have a very long orbit, so we wouldn't see it, and it may be at its furthest point right now, which means, if depending on what it's made of, it might be a very, very low albedo, which means you wouldn't really see it because it wouldn't reflect much light. So then you'd be limited to sort of infrared type observations to try and find this thing. And we already know how freaking hard it is to find, comets and stuff like that out there if they're not luminous. If they're luminous, it's not too bad, because you can just watch a piece of sky and then look for a moving object between, over a time frame. But if it's really dark, you can't do that. So this is the idea that maybe there's an object somewhere between 5 and 20 times the Earth's mass, and it's in this really eccentric orbit, and that at some point maybe it was a rogue planet perhaps that was captured by the sun, which is possible. We do know there are rogue planets. We covered that on this show as well in the past, so that could have been it. And if that happened, then basically during its orbit around the sun, it could have actually been enough to pull the planet's orbital plane out of alignment with the sun. So there's already a very strong relationship in the orbits between the gas giants and the ice giants. So they have a certain amount of resonance. So you muck around with one, you muck around with them all. So it wouldn't. It's not like this planet would have had to pass them all individually or anything, because of the way that they interact with each other. You know that would have been like a bit of a pinball effect. So
so it tugs at one, which tugs at the other, which tugs at the other.
Exactly. Yeah. So that's a possibility, but there's nothing been discovered per se. It's just a model. It's a model that's been running at Caltech, and they've found that if they do plug this thing into the models, it does actually explain things quite well. Doesn't mean it's the answer, but it's certainly a tantalising possibility.
Yeah, I was a little bit sort of sceptical when I first read this, because I thought, it's so far out, and it can't possibly have that significant an influence on the planets. But then, of course, I thought, now it's so far out, but it probably would have been a lot closer early in the solar system's development, and it probably had more of an effect earlier on.
Yes, and if it was on an eccentric orbit because it was a captured object, then it might be quite wildly different, as indeed Pluto is, and a lot of the Kuiper Belt objects are. It could be on a very different orbital plane to what the planets are on. So it might, over eons come into towards the sun, getting closer and closer, but because of where the planets happen to be at that time, it might only have a fractional impact on just one of those ice giants or gas giants. So you multiply that over, millennia, these tiny little tugs that occur that then ripple out through the rest of the planets. That's what we're talking about here. These are really, really small interactions. And I've mentioned, I think a couple of years ago, there's a website that I really enjoyed playing around with back then, which was, I can't remember what the site was now, I apologise, you'd have to Google it, but there's a site that you can go and basically play around with orbital dynamics. And there's this thing called a three-body interaction, which is if you have two bodies either in a common orbit or orbiting each other, as in fact Pluto and Charon do, they orbit each other around one central point. If you have those, they can be quite stable because they orbit a common center of mass. But if you bring another body into the equation, another massive body, then you end up with this three-body interaction, which often throws one planet completely out of the system, or one body completely out of the system. Things in threes don't like to play in orbits. So it's kind of cool sort of seeing that happen. And, I like to imagine this when it comes down to things like supermassive black holes in the centers of galaxies where, there can be really crazy orbits going on here with different stars, orbiting around these black holes. And occasionally there'll be a three-body interaction where one star happens to get close to another star and both of them are orbiting that supermassive black hole. And then before you know it, we've got a star being, thrown at great velocities out of its galaxy on some weird sort of slingshot orbit, which is exactly what can happen. So, bit of a tangent, sorry.
Yeah. No, that was very cool.
But it is entirely feasible that this could be the case, and if it's on a sufficiently eccentric orbit with going sufficiently far out, we quite possibly wouldn't have actually seen it in modern times to record its existence as a planet. So, yeah, could be. And you add this up with other lines of evidence and other proposals and ways of explaining certain bombardment periods and certain changes in atmosphere and so forth of Earth. Who knows? There could be one out there. It'd be really cool if there was. I mean, that would be an awesome discovery.
I would say probably Nobel Prize winning discovery, really, if we could identify and find it. But
yeah, agree.
It's such a challenge to find it, particularly since we believe it's so far out, and it's probably also between Earth and most of the Milky Way. So where there's a lot of bright light coming towards us, and you're looking for something reflecting the sunlight, it's very, very difficult. But very, very cool. And I think we'll leave it there. For more information about the stories we talked about today, check out our website, scienceontop.com/235, and you can leave a comment there or on social media. Don't forget you can email us, feedback@scienceontop.com. We really appreciate the reviews that people leave us on iTunes. And thank you for joining me today, Lucas and Shane.
No worries.
Thanks, Ed.
This episode was edited with style and a fearless spirit by Marcos Benamou. Thank you everyone for listening. We'll be back again next week putting science on top of the agenda. Join us then.
They said that you called climate change a hoax. Is that true?
I want clean air and I want clean water. And if you look at what's going on in China and all of these other countries that talk but they laugh behind our back at what we're doing, we want clean air, clean water. I've gotten many environmental awards. Believe me, I know what I'm talking about. But we have to have crystal clear water and crystal clean air.
Okay, but did you ever call climate change a hoax?
Well, I might have.
I believe in science. I believe climate change is real and that we can save our planet while creating millions of good-paying clean energy jobs.